Hi, my name is Ritesh Babu from Drake Middle School in Auburn, Alabama. My topic of research is the effect of alpha amylase concentration on the rate of starch hydrolysis. Alpha amylase is the digesting enzyme made in the salivary and pancreatic glands. Alpha amylase digests starch in the mouth and small intestines into glucose. Alpha amylase maintains a normal blood sugar levels and helps treat diabetes. Lower pancreatic enzymes are very common in people with pancreatic cancer. The purpose of this study is to determine whether the concentration of alpha amylase will affect the rate of starch hydrolysis. The hypothesis is that increasing the concentration of alpha amylase will speed up the rate of starch hydrolysis. So I conducted the experiment with 3 different concentrations of alpha amylase and determined the rate of starch hydrolysis by an iodine test. When I added 1% starch to the iodine solution, a dark blue color was observed. Similarly, I added 0.0625%, 0.125%, or 0.25% of alpha amylase in the iodine solution, and the yellow color was observed and used as control. I used them as controls. The color-coded chart was made based on the disappearance of the blue and appearance of the yellow color, which is shown right here. For the iodine test, I added equal volume of 0.0625% amylase and 1% starch. Immediately, I added this solution to 1 drop of iodine in the 24-well plate. Every 10 seconds, I repeated these steps until the blue color turned into the yellow. The 24-well plate, and this is the 24-well plate, and it starts at 0 seconds and goes up into 230 seconds. Based on the color chart, the table was made, number 1 being the blue iodine color and 9 being the yellow color, which shows the starch hydrolysis. This was repeated 3 times, and the mean value was given. So, for the 0.0625% alpha amylase, the starch is hydrolyzed to 230 seconds. This was also shown for the 0.125% amylase, and in this case, the starch was hydrolyzed at 140 seconds. Similarly, I did this for the 0.25% amylase. In this case, the starch was hydrolyzed even more faster at 80 seconds. The results are shown in the line and bar graph. This shows that the 0.0625% of alpha amylase hydrolyzed the starch at 230 seconds, is 0.125% at 140, and is 0.25% at 80. This was further confirmed with the Benedict's test. I added 1% starch to the Benedict's reagent and boiled and gave a blue color. But when I added 1% glucose to the Benedict's reagent and boiled, it gave an orangish red. I used these colors as my controls. But when I added 1%, for the Benedict experiment, I added equal volume of 0.0625% to the starch, to 1% starch. I added solution to the Benedict's reagent and boiled. It gave a blue color, as we can see at 0 minutes. Every 1 minute, I repeated these steps until the Benedict reagent color changes to red, as you can see in 4 minutes. So, for 0.0625% alpha amylase, the starch was hydrolyzed to glucose before 4 minutes. This was also done with the 0.125% amylase, and the starch was hydrolyzed before 3 minutes. Similarly, I did it for the 0.25% amylase, and the starch was hydrolyzed before 2 minutes. This confirms that the rate of starch hydrolysis is dependent upon the concentration of alpha amylase. Thanks for listening. Bye.